In this question, we're going to be completing a nuclear equation and figuring out if this is a fission or fusion reaction. We're told that an astatine 197 atom is bombarded with a proton. It then undergoes a reaction to form a ruthenium 84 atom, one other atom, and 6 neutrons only. Let's start with our astatine atom. We'll head to the periodic table. Here it is. Astatine has an atomic number of 85 and a symbol AT. So our symbol is AT and our atomic number was 85. We're told it's astatine 197. That's the mass number. Then it's bombarded with a proton. So we're going to have P for our symbol. A proton has an atomic number of 1 because atomic number is the number of protons. The mass number is the number of protons and neutrons together, which is just 1 because we've got 1 proton. We're told it forms ruthenium 84. Let's head to our periodic table again. Here's ruthenium. It has the symbol Ru and the atomic number 44. So we've got Ru for ruthenium, atomic number 44, and we were told it's ruthenium 84. So that's going to be our mass number. We're told we've got one other atom. So this is our unknown atom here. And we're told we end up with 6 neutrons. So we're going to have our neutron. Neutrons have 0 protons in them. So our atomic number is 0. But their mass number is going to be 1 because that's the protons and neutrons together, which is just 1 neutron. And we've got 6 of them. Alrighty, so now we're going to have to go ahead and add up our mass numbers on the top and our atomic numbers on the bottom to figure out what are the missing mass and atomic numbers for our unknown atom. So let's start by looking at our mass numbers. In our reactants, we've got 197 and 1. So we've got 197 plus 1, which gives 198. Then in our products, we've got 84 for our ruthenium atom, plus our unknown mass number, I'm going to call it M, plus we've got 6 neutrons, which is 6 times 1, so 6. I'm going to simplify that a bit. 84 plus 6 is 90, so this is like 90 plus M. Then for our atomic numbers on the bottom, we've got 85 plus 1, which is 86 in our reactants. Then in our products for ruthenium, we've got 44, plus our unknown, which I'm going to call A. And then we've got 6 neutrons, but the atomic number of a neutron is just 0. So that's going to be it for our products. Okay, so our mass numbers are going to be equal for the reactants and the products. So 198 is equal to 90 plus M. So to get M, I'm going to do 198 minus 90, which gets 108. And then for my atomic numbers, I've got 86 in the reactants is equal to 44 plus A. So A is going to be 86 minus 44, which gets us 42 for our atomic number. So we can go ahead and fill those in. So we've got 108 for our mass number and 42 for our atomic number. Let's head to the periodic table again to figure out which atom has an atomic number of 42. Here's our atomic number of 42. It's molybdenum, Mo. So our symbol is Mo. Our name is molybdenum. And our mass number for that is 108, which is the number that goes after the name. Awesome. So we finished writing out our nuclear equation and figured out our unknown nucleus. Our last step is figuring out the name for this process. Is it fission or fusion? Well, in this reaction, we started with a really big nucleus, astatine 197, and then we ended up with 2 smaller nuclei, ruthenium 84 and molybdenum 108. So this reaction is going to be nuclear fission which means splitting up, because our really big nucleus was split into two slightly smaller ones. And we also released some neutrons in the process.